Now, just a reminder, Pythagorean's theorem, that allows us, when we have a right triangle, it has to be a right triangle. Remember, it doesn't work if it's a non-right triangle. You've got to have a right angle in there. Pythagorean's theorem says that if you know two sides of your right triangle, you can find the third side by using that formula. And the formula for Pythagorean's theorem, that is a squared plus b squared equals c squared. And then I'm going to draw a quick example of a right triangle to explain to you what the A, the B, and the C represent. The C is the hypotenuse. The hypotenuse in a right triangle is the longest side. It's also the side that is opposite the right angle. So that side there is always going to be the biggest side in your right triangle. That is what we refer to as side C, or the hypotenuse. The other two sides here, and these other sides, you notice that those two sides are making the right angle, right? Those two sides make that right angle. It doesn't matter which one you label A, which one you label B. So I can write A, and then I'm going to also write B, and in the middle, I'm going to say or. Because it doesn't matter which one you write that as. One can be A, one can be B. Those don't matter. The legs don't matter. The hypotenuse is what's important. That is C. That has to be your C squared. Okay? So looking at B, if we're going to use our formula, okay, let's start with C, because C squared is the most important. Looking at our example for B, what does C equal? What is the hypotenuse for B? It's 96. Right up here. I'm going to zoom up here so I can show you. That is the side that's opposite the right angle. Okay, that's what we're going to write for our C squared. Now, the other two sides, it doesn't matter which one goes first. Okay, you could write it as 20 squared plus x squared, or you could write x squared plus 20 squared. Those don't matter because you're just adding them. And when you add numbers, you can change the positions. 96, though, has to be on the outside there. Okay, so now we can just solve this. Again, you're probably getting very tired of me saying this. Geometry sets up the equation. And then once you have the equation, this is just an algebra problem for us to solve. Okay, so let's get our calculators out because it might be helpful here. 20 squared. So I don't know that off the top of my head, so I'm going to type in 20. I'm going to hit the squared button there. It looks like 20 squared gives us 400, so this turns into 400. Plus, that's just x squared, so I'll leave that as x squared, equals 96 squared. So I'm going to type in 96. I'm going to square that. Got a big number, 9,216. I want to solve for x. So let's subtract that 400 on both sides. I'm left with x squared equals that number minus 400. And that gives us 8816. Now that's what x squared equals. I want what x equals. So to get that, I need to square root that right side. And the square root of 8816, again, I don't know that. Yep, looks like it would give us a decimal. Looks like it's 93.89, I would say 4. So 93.894. That is the unknown side of our right triangle. Okay, I'm zooming out so you can see the picture again. That's how you solve that out. You got to just put in, where does your A, your B, and your C go? Once you have it in there, it's just math and algebra solving to get what x equals. Okay, any questions with B? Because I do want to try C as well before I let you go. I'm not seeing any questions here. Let's do C now. So for C, Again, let's start off with our c squared. Looking at the triangle for c, which side represents your c? Yeah, it's the x. Again, if you ever want to find out what your c is, I always just draw a little line from the right angle. That right there is what x is. Okay, x is your c. So I'm going to go ahead over here and write x squared. Again, the a and the b, it doesn't matter which way you put those. So I'm going to do 16 squared plus 42 squared. That's our equation. Go ahead and solve it. Let me know what you get for x. So again, we just want to start solving this out. I'm going to go ahead and type in 16 squared because I don't know what 16 squared is. That makes 256 plus 42 squared. That makes 1764. That all still equals x squared. So then I'm going to get my calculator and add those two. So 1764 plus 256. That made 2020. Oh, our favorite year. Look at that. 2020. It equals x squared. Again, we want what x is. So we're going to write x equals the square root of 2020. And the square root of 2020 is 44.944. 44.944. The reason why I wanted to do B and C is because those are the only two examples for Pythagorean's theorem. Let me be super clear. It's either you're solving for a leg. If you're solving for a leg and you don't know, and you know the hypotenuse, this is what your problem will look like. It will be you having to subtract the number and then doing a square root. If you're trying to find C, it's a little easier because you just have to add those two legs together once you square them and take your square root. But those are the two possible combinations for a Pythagorean's theorem problem. It's either you're solving for a hypotenuse or you're solving for a leg. So I would rather you guys try A and D on your own now. A and D are two other examples you can do by yourselves. And again, it's either going to look like B or it's going to look like C. That's where we're at with that. Okay? That's how we do Pythagorean's theorem when we have a right triangle.